Hi, everyone. Welcome to ProjectPro Expert Talks. We are excited to have Tirtha with us today. Tirtha is based in the San Francisco Bay Area. He's a data science and data engineering expert in Industry 4.0, which he will talk to us about later in the chat. He also has a very interesting background. He did his undergrad at IIT Kharagpur, did a master's at Georgia Tech, PhD from University of Illinois, Chicago. And he spent most of his early career as a semiconductor engineer at Fairchild and on Semiconductor. And then midway, he made a transition from being kind of a hardware engineer into a more data science role. And we're going to learn more about how he did that in this call. And he's currently a data science engineering manager with Adapix. Tirtha, thank you so much for taking time for us today.
Thank you. Thank you for this opportunity. Thank you for having me.
Great. Awesome. So Tirtha, I probably want to just start off by, there's this term we all hear of today, Industry 4.0. It's all over the place. What exactly does it mean? If you could help us understand.
Yeah, you will hear it. And I was looking at a documentary and it says that this Industry 4.0, this specific term was coined in Germany. And in Europe, they call it more often in the same term in US or North America, they call by smart factory or smart manufacturing. So it's a kind of interchangeable terms. Yeah. Basically, it's the fourth revolution of how mainly the manufacturing industry, and manufacturing means everything. You can manufacture from electronic items to drug or healthcare vaccines like going on these days, right? So everything falls under this. So you can think the first industrial revolution was about steam power and transitioning from animal power, horsepower to steam. The second one was about assembly line, like the Henry Fords, which introduced electricity for faster manufacturing. The third one actually introduced computer and digitization and programmable logic controller to control the equipment. But it was, I can say, dumb electronics. You can say, I mean, they didn't have much intelligence or interconnectivity, right? I mean, you had to go to a factory floor to set something, even in a programmable logic controller. If you have done any work in the factory floor, you'll know. The fourth one is actually taking the power of data analytics, basically the cloud and the internet and the TCP/IP connection, etc., to take to the next level. So it's a digitization, but on steroids. So basically, you are connecting all the equipments there, and IoT, of course, right? So all the equipment, sensors, you are making decisions based upon that, and automatic decisions. Robotizations of the factories, etc. So this is all coming together. So this is like information and intelligence steeped into the manufacturing flow. So that's Industry 4.0, I would say.
Okay.
And if you read about it, some resources actually, if you type in Google, there are many companies, like big companies like IBM, Google, and Accenture, Intel. Everybody has their IoT/Industry 4.0 page. Two of those pages, what I like most is IBM has fantastic description, and Accenture, actually, they have a fantastic description of the Industry 4.0. So you just type in Google the Industry 4.0 Accenture, and you will get to know about the latest developments there, because they are a big player.
Okay, super. That's very helpful. Those resources are very helpful. Would you mind kind of taking one specific industry scenario and a set of machinery and IoT sensors, and helping us understand a specific use case which Industry 4.0 delivers on today?
Yeah, so there is actually a good paper which looked at what kind of machine learning algorithms are being used in Industry 4.0 or smart factory, smart manufacturing, and all over the place. So you have unsupervised learning, supervised learning, and regression, deep learning, etc. I will take probably one example from unsupervised learning and one from the popular deep learning to just give you very quickly the example. So the anomaly detection in any process is very important. As you know that like imagine I don't know, maybe a vaccine manufacturer. We take the example fictitious COVID-19 vaccine, and it's ultimately you're producing a very complex protein or chemical, and then so you need to control, say, temperature, pressure, and humidity of the plant or the tube through which the vaccine is being manufactured, right? I mean, the DNA or RNA. But then, so you are monitoring that using sensors, and they are all over the place. But maybe the gas flow is not uniform, etc. So sometimes the temperature changes and pressure changes, drops in some portion, and you have an acceptable range, but basically there is a statistical variation to it, all these variables, right? So earlier there was a fixed limits, and it came from experience. So process engineers used to go and set this limits. These days you are continuously monitoring the statistical distribution, and then you are looking for anomaly based upon the previous data points as well as the other points. Almost it sounds like a nearest neighbor problem, like you are determining some kind of distance metric, and you're clustering the common points or normal points versus abnormal points, right? So you're doing effectively a clustering problem solving here. You can take any algorithm. You can take Gaussian mixture model or neuron RBF. All kinds of algorithms exist. I do not want to go into details, but you can see that unsupervised learning, because there is no label. I mean, nobody says this temperature is good or bad. You are just trying to say this data point is normal or does it look abnormal, right? So you can use standard machine learning for that, I'm sure, right? You can understand. So now once it's automatically detects some points as abnormal, and if the frequency of that abnormal points is too high, then what Industry 4.0 will do, the system will automatically send an alert to operator, to plant manager, to decision maker, and they will come in. They can even remotely log in to see on a dashboard. So all these things like connected together, because you have internet connectivity, and then you have fancy APIs built on top of it. So basically you are looking at all the dashboards. Some plant manager may be in another country, right? But he suddenly get an alert on his cell phone app that basically some temperature fluctuations is happening. So he looked at it and he called a technician who remotely logged in and kind of set something else. He can robotically kind of change the flow of a gas or something like that, a thermostat, right? I mean, all this smart thermostat, it can change the new set point. So these things are happening without any human intervention much on the factory floor. This is an example where machine learning gave you the indication and told you that something going on automatically, right? So this is one example. And another big example is that defect metrology. So by metrology, I mean measurement of the defect. So just by looking at it, I mean, all the time you can understand that something comes out of a plant, some kind of, maybe you're making a toy, or you're making even a chocolate. I used to work in a Cadbury factory in my undergraduate intern time. So they used to literally look at the chocolate width and bar. It's in Pune area, right? So that is actually an interesting thing, because when you say you look at it and you determine something is good or bad, you can now imagine that using deep learning, you can pretty much replace that. All the human knowledge and all the fixed rules of computer vision or image processing techniques you can replace by deep learning. So if you're printing a circuit board, then basically what can go wrong just by looking at it, and you are classifying good or bad, and then you are making scrap, right? So automatically, a lot of these machines have camera built in, but earlier generation, they used to have simple image processing algorithm built into that. These days, they have on top of that intelligent deep learning algorithm built on that inside the camera system. And the people who used to sell the hardware of those camera systems and the whole machine inspection machine, they are now hiring data scientists or machine learning engineer to write algorithms for them, so that they can also sell that as a top of extra feature or license or something like that, like the software license. So this is another prominent example. You should know that Andrew Young, which is very famous, we all know from Stanford. After Stanford, he moved to different companies, but he founded he has deeplearning.ai as an educational initiative, right? But he founded another company called landing.ai, which deals with smart manufacturing and application of deep learning to smart manufacturing. You can check LANDING, landing.ai. So it's geared for applying machine learning for manufacturing problems, and he solved this problem. And some of these problems are pretty interesting, because you'll not get too many data, because these are expensive products coming out. So you've got maybe 100, 200 data, only with how small data points you have to train a deep learning algorithm. So that itself a challenge, right? Contrary to our conventional view, we'll have thousands of GBs of image and stuff like that. So that's one interesting example.
Very interesting. Those two use cases sound very, very powerful, but also they sound quite technical. And I was trying to understand, how did you find your way into this? Coming from a semiconductor background, how did you make the transition to doing data science and eventually Industry 4.0?
Yeah, so there is actually a course I was doing, and then somebody from Google talking about it, that in Google back in 2005-06, they started doing this big scaling of the Google systems, right? So you may know Hadoop and all these things, it came from Google file system.
Yeah.
So they they looked at it and they started doing this in 2005-6. They are not doing much machine learning then. They were doing some rule-based search and map and all those products coming out, Android, etc. So they realized that any problem, engineering problem, which is ultimately leads to an engineering decision making, right? So then you deal with data, right? You make data-driven decision, not just somebody says it is good just because of that, right? I mean, you take the data, you make some measurement, experiment, and then when this data explodes both in size and in variety, that means its dimensions are exploding, then you cannot do rule-based learning. So I realized exactly the same thing in my domain also, that I was doing semiconductor design, and the design problem has so many variables at different stages that I noticed that, let's say we do a design this year, and we, based upon what? Based upon looking at some graphs and plots and some experimental results, etc. And then we make a good design, and then we kind of forget it, or we have it in our memory, and next year comes another similar technology development, and then somebody says, oh, I remember that we did this decision, then it led to this, but this did not lead to other decision. So you think this is a similar to a decision tree already you're doing, but you have never stored that model anywhere. You're not digitized that, right? So I realized a lot of engineering decisions we do in design, in manufacturing, we do based upon gut feeling or like our hunch, but this is not scalable or sustainable, right? So you have to use, and then why not use which is already existing data science and machine learning? Simple. I'm not talking about fancy, big, deep learning or anything like that. Even start simple decision tree or logistic regression. Just digitize the experience of an engineer, right? And you will find it in your work many times. You are doing something repetitive, something decision making in your work based upon certain variables you're looking at. You can automatize it if you just started collecting the data and then apply simple machine learning, right? So that was kind of motivation. And then I explored all the ideas, and then we were in the hardware making business, so we also went into how to put intelligence literally inside ICs or semiconductor chips, which were not intelligent before, right? So how to even burn in the neural network. So there is a different kind of challenge, because we're dealing with small controller kind of IC power controller. So there, even the space is very little. The physical silicon space. So there's a different challenge. You have to do a very efficient neural network design or efficient machine learning design, which can be turned into a hardware and then put into the chip, right? So all kinds of different problems I got interested in. I started doing all those projects. Then I transitioned to new goal, which is a little different.
Interesting. That's a very interesting story. Okay. And as you transition, did you make the transition first inside your current company, or did you make it in your next job? How did that happen?
Yeah, very interesting question. And this is actually relevant to a lot of the folks who may be listening who are in a different type of job, maybe related to, maybe you were a web developer, maybe you were a finance analyst, maybe you're an electrical engineer, maybe you were a mechanical design engineer, etc. Right? So you have to learn. So I had my day job kind of responsibilities, and then on the parallel, I was picking up all the tools, programming, etc. Because in my day job, I was a semiconductor designer. I used to do coding, but totally different type of coding. It's like a simulation, physics-based simulation, etc. Nothing related to actual programming styles, learning Python, or even some web app or web technologies like deploying the machine learning, etc. So I picked up on the side, and so that effort you have to do, and it's best that basically you are doing it while you have a steady job, right? And because you that kind of stuff. But then it is good that basically you have to push the ideas in your own organization, and whenever you find a chance, you have to take this extra thing, because generally nobody will create a machine learning project for you if they're not doing it, machine learning in your organization, right? So you have to create this opportunity for yourself. You have to tell your manager that, okay, I understand that you were using this simple software like an Excel regression fit. I can do it better with a Python script, and I'll automatize it. Next time you throw the data, I will just give you the plot in 2 minutes instead of going back and doing it manually in 20 minutes. You see the results, and nobody has to follow it. I will do it, and I will learn it, and I will give you the result, right? At the end of the day, your manager just wants the result, just a plot for his presentation or showing to his manager, right? So nobody cares. So you have to learn on the job a little bit and find opportunity across the departments, across the different kind of organization within your organization or company. If somebody is interested, and you'll find a lot of people, they are interested, they do not know where to go, how to get the data, etc. So you can talk, form a kind of group or friendship group, etc. So that's how I started, and then of course I realized that doing two things, because of like I was a senior principal level designer of semiconductor product development and technology development, and I wanted to spend more time on these new technologies, right? It was not working out so far, so that I kind of transitioned to a full-time data science role when I got the opportunity. But I specifically transitioned to a company or a role which deals with like this industry 4.0 or smart manufacturing, because at my stage of the career, I have always dealt with like actual hardware manufacturing or electronics manufacturing, etc. So I had this experience, which is called domain expertise. Very, very important, right? So it does not matter if, let's say, you are associated with an electronics company and next time you join a healthcare company, right, which produces drugs or like medicines, right? They will go through the same thing: design, and then production, and then quality check, etc. Supply chain, so raw materials, etc. Again, the same thing, like whichever is involved in an electronic toy manufacturer and the drug manufacturer. The end product look different, but the basic management principles and the life cycle of the product, everything will be very similar. So you can transfer your domain expertise that way also. So I wanted to only go to a data science role where I can apply my domain expertise also. That's why not like Amazon or Facebook or that kind of stuff where you just deal with click data or movie data or liking a product. Not that. I wanted to go where I deal with the actual physical goods and their production, and then improve them by applying the data science.
That's super. And I think it's a great takeaway what you just said. You have to make your own opportunities.
Yeah.
I think that's very, very helpful to the people listening here. Yeah. And now, since you're on the other side of the table right now, and when you're trying to hire people for your team, what is the single most gap that you see that exists in these people that you interview?
Yeah, so maybe I can just give you some examples of some of the, maybe couple of examples what I look for in such a data science interview.
Please.
And then I will tie that to the, I guess your question is about the gap in the skill training for data science, which goes on in many places, right? So I can tie that. So for example, I have made some notes. So a couple of things that I look for, or maybe 2 or 3 things that like, I look for if they have understood the deeper meaning actually of, or the origin of, let's say, a machine learning algorithm. And I'll give a specific example here to make it just clear. So maybe I'll ask why logistic regression is called regression, although it is mostly used for classification, right? So I'm not asking if the formula or like writing a code or anything like that. I want to understand what is the logistic regression, why it is called regression, right? I mean, can you use it for regression? Can you use it for classification? And what does it mean, right? So that's one question. Other questions like, give me an example where a scenario where you have, let's say you have a classification algorithm, you have trained machine learning and you get 99.8% efficient accuracy. Give me an example where that is no good, right? I mean, it does not mean anything. So I keep it that way. I mean, that much question, and then I will let him explain what he means, the interview. Then I am also looking for if they're thinking beyond the immediate tools and the methods that they have learned in their program or class or bootcamp workshop. So basically, I will ask the simple question: how to solve? Let's say we have a 2-layer neural network, right? And you are not allowed to use gradient descent algorithm. So how do you solve that problem? You still need to solve the neural network. That means you need to get the best weights, right, for the neural network. I mean, you have training data, but you have to write code. Not write code on the interview. Just tell me how you solve the problem, right? Without using gradient descent, the neural network problem, right? And the most important thing I also look for is that if they can, in these resumes, I mean, if you get the candidates, they always will have some project description that they have done previously, right? Yeah. So I look for something which is like team project, right? A couple of people, 3-4 people they have done. And because from the description, you will know that this is not a one-man job, right? I mean, so basically, you know there's a team project. Generally, all the corporate projects are team projects. So I want them to explain in clear and unambiguous terms the specific contribution they made to the team project. It is very important that you understand your role, your responsibility, your limitation, and how you integrate very quickly with the others in the team project also, right? It is psychological kind of thing that basically when you go for interview, you try to say, oh, I did everything, but I mean, I know all of the aspects of the project. Yes, you may know all the aspects of the project, but not in the same depth, right? So basically you have to acknowledge that. And also so that because it's very important for your hiring manager to know that what you're good at and what you're not, so that he can train you. It's not judgment that on your capability. You simply add chance, but if you can show that basically you did a very specific contribution to a project like a big website building, you did just database part, but you also looked at some HTML front-end design and you learned about it. You never got to apply on that website. Maybe you have a very simple website of your own, like you built based upon the knowledge you gained there, right? So that actually shows that you have initiative to learn a technology based upon a team project where you did not get the chance, but then you applied to a very simple like prototype, right? And then this kind of example actually stands out in the resume, I would say.
Okay. Super. So that's very helpful. So just in summary, number one, you look for kind of a deep appreciation and an honest, sincere interest in the field, so they know what terms mean and they're not just like memorizing things. Yeah. And number two, just tangible contribution to projects they have worked on.
Right. And fantastic. Knowing their own likings and how they can contribute. I mean, how they can say that I think I like this thing more, and that's why I went into there. So I think I can contribute to your company's bottom line or your project or something like that. Fantastic. Sometimes I give some example, of course, what projects we are doing and then how they can help, right? Just any kind of solution they can come up with. Yeah.
Yeah. Okay. Super. And I also noticed, Tirtha, that you're a editorial reviewer for what is probably the most popular destination out there for data scientists, starting off, which is towards data science. What are people looking to read these days? What are the most common, most popular things you publish there?
Yeah, so this is an interesting question because TDS, I was associated with it from the beginning with the editor. He's based in Canada. Also in India, there is a person, Tirthajyoti Sarkar, who was also the editor. You probably know him. Tirthajyoti is a good friend of mine.
Oh, nice.
It kind of have evolved, but people still publish. If you see just the frequency and volume, there are a lot of publications like how to do a linear regression and stuff like that. I'm not demeaning that anyway, right? Yeah. When you start learning, you have to do that. But publication point of view, because these days medium even under paywall, right? Behind the paywall, somebody has to pay to get to that article. So it's not that much value. So I have some examples actually I listed down. This is based upon more so like what I wrote, and I'm also like a prolific writer, and I have 100,000 views per month, etc. So I can get a good idea that where people are reading more, right? Because I get all the statistics there. Yeah. So one thing is that few of the topics which people are interested in reading about is say a new data science package and library and how to use it to solve a real problem, good problem, like not another visualization library, but something which improves your speed of your code or clean your code, etc. Some kind of new ideas. Then sometimes a new AI or ML tool or open source tool from the big tech like Google or Facebook or NVIDIA or Airbnb or all those things. They sometimes publish like the Jupyter notebook replacement, like not replacement, but enhanced version Polynote or something came out, which is from, I guess, Uber or something, like those kind of, tools, discussion about it. Then also I have written many articles which are very popular, which is a demonstration of a statistics concept and or machine learning concept using like a simulation, like data generation. You generate synthetic data and then you explain it. Very simple example is that the limit theorem, or basically in the statistics, like everybody knows, okay, normal distribution. So what is the definition of central limit theorem, right? The definition is not very intuitive. It says that you have to add different distribution, no matter what distribution they come from, and then they will lead to the mean of them attain to the central limit theorem. So all these things are very jargon and could be difficult. Start with throwing dice, like you write a Python program which basically starts throwing dice and generate numbers, And that is a uniform distribution, or you can choose anything from NumPy, etc. And then you add them and you see how their mean going. You add 5 of them, you add 500 of them. So you do it programmatically, you show them how it is. So basically this is a demonstration of a concept using very simple thought experiments or like a programmatic experiment. So that kind of article is very popular. It clears the doubt once and for all for a lot of young learners actually.
Okay.
And also, I guess some of the deployment topics are very popular. Like how do you take machine learning and from your Jupyter notebook is great, but then basically how do you make an app out of it, or Python package out of it, or deploy it to an AWS or something like that, the full life cycle, how to do it step by step, how to write documentation for it. All these things are very like guides, right? They are very popular articles.
Super, super. This has been a fantastic session. Lots of tangible things I think the viewers can act on after this. Really appreciate taking your time. Thank you very much.
Thank you.
Yeah, thank you.